just going to do a few more examples. So again, we want to work with 2s, 3s, and 5s so that we're not doing change of base in our calculator. Well, actually, you couldn't do change of base because you don't have a value in the A spot. Excuse me. Okay, so we want to work with the 18. And we're asking ourselves, what could we do to rewrite this so that we have a combo of 2, 3s, and 5s? Could we do like 2 squared, 2 to the third? Does that equal 18? 3 to the fifth. What would work, right? 5 times 3. Okay, so when we look at that combo, it doesn't matter how you come up with it. Any arrangement, as long as it becomes 18, would work. We look at this and we go, oh, we could do 3 times 2 times 3. Or obviously 3 times 3 times 2, same answer. 3 times 2 is 9. What am I saying? 3 times 2 is 6. 6 times 3 is 18. Okay, now, next step. We're working with 2s and 3s, which is what we want, right? 2, 3s, and 5s are allowed in order to figure this out. So we then know that we're dealing with products, and we know that multiplication goes with addition. So what we're going to do is we write log base A 3 times, right? We're going to expand, and we use addition for both. Okay, now we can do replacements. If we know log base A of 3 is 0.5646, which we know, we look up here, right? Then we look for log base A of 2, which says 0.3562. Then we look for log base A of 3 again, it's 0.5646. And then we add them, and we get 1.4854. Okay, again, for 100. So what combo of 2, 3s, and 5s? Anything squared, anything cubed, square root of whatever, right? We couldn't do square root of 100. We could look at this and say, okay, what combo? We know 5 times 20. And we then, okay, now we have a 5 in here, but we can't have a 20. So we could break that down into 5, right, times 2, which is 10, times 2, which is 20. Okay, 5 times 5 times 2 times 2 would get us 100. And we're working with 5s and 2s, which are allowed. So then we can look at this, and we can, instead of writing log base A of 5 plus log base A of 5 plus log base A of 2 plus log base A of 2, you could do that and then just add these values, right? Add that twice. Or if you write 5 squared and 2 squared, right? Because we have 2 5s and we have 2 2s. We can do this and make it a little shorter. So we know that multiplication goes with addition. We have same log base, right? This is technically expanding. You do multiplication and division first when you're expanding, and then write addition, subtraction, and then lastly you bring down those exponents, right? The product is a product. So when we do that, the 2 comes in front. This 2 comes in front as well. And now we know that log base A of 5 is 0.8271, right? And okay, so this is not right. Okay, so log base A of 5. Log base A of 5. Sorry, I made a mistake. So log base A of 5 is 0.8271. 0.8271 plus 2 times log base A of 2 is 0.3562. 0.3562. And when we do that, let me use my calculator. So we get 2 times 0.8271 equals Sorry, I'm taking a sec. I'm doing this on my phone. It's getting messed up. Okay. Plus 1.6542. Okay, so we get 2.3666. Okay, so that's our answer. Okay, so I think overall, hopefully, you guys are picking up this idea, right? So you're figuring out what combos you can take these numbers and create 2 3s and 5s. Another one, right? Like this 25 is just like the last one, right? So 30 we can replace with 5 times 3 times 2, right? And then we know that product goes with addition. So we write log base A of 5 plus log base A of 3 plus log base A of 2. And then we look up top and do our replacements for those 3 values, which are given. And we get 1.7479. So then when you look at this next one, you usually want to change radicals and put it in exponential form. So you see an exponent. Now we know that square root is written as 1 over 2, right? So we can rewrite this as 3 raised to the 1/2, right? To expand, you bring that exponent down in front. And so we have 1/2 times log base A of 3. We can replace log base A of 3 with 0.5646, and you multiply that by 1/2. And when you multiply by 1/2, you will get 0.2823. So we do the same thing for 27. So for 28, we want to work with 2 3s and 5s. So we can write 4 as 2 squared, 9 as 3 squared. You first get rid of the division. We know that goes with subtraction. So we write log base A of the top term minus log base A of the bottom term. And then we want to bring that exponent down in front. So we get 2 times log base A of 2. We get 2 times log base A of 3. So we look at the value for log base A of 2, which is 0.3562. We look for log base A of 3, right, 0.5646. And then we have those values right in front that we would multiply by. So 2 times 0.3562, get a value. 3 times 0.5646, get a value. And then find the difference. So it's negative 0.4168. Okay, now just realize that this, right, this is not this is not 15 raised to the 1/2. A lot of people, when they see radicals, just assume they're square roots, right, or call them square roots. This is a cube root, right? You have a raised to the m over n. Right, the m is the power on top. So this is the base. So we write the base, and then we write raised to whatever exponent we see on top of it. If you don't see one, you can write a 1, which means I just have 115, right? So it's the base raised to whatever the power is on top of that base over, the index. The index is the number right in here. If you don't see it, you know it's a 2 because you know it's a square root, but we see a 3. So this is actually 15 raised to the, there's a 1 technically on top of the 15 because there's 115. So it's 1 over the index 3. So that's why it was written like this. Now we can break apart 15 into 5 times 3. Right underneath this cube root, you can break apart and write 5 times 3 because that's 15. And they both have a third as a power. And you're just doing what we did. We want to work with 5s and 3s and 2s. So we break apart multiplication with addition. We write log base A of 5 raised to the 1/3. We bring that 1/3 down in front. So we get 1/3 times log base A of 5 plus, we bring that 1/3 down in front. Log base A of 3 goes after. And then we multiply log base A of 5 times a third. We multiply log base A of 3 times a third. And then you can do the rest and get your answer. So the same thing for 30. Okay? So now you're going to try your practice sheet, reviewing, expanding, and condensing. So again, we did some of the harder ones today. Last week we did some of the easier ones just to take a sec to review. We if we look at number 14, you're going in reverse. You first bring anything that's a product for a term back on top. So that's why we got log base 10 or log of x squared, right? This is common log plus log, if you want to write base 10 of 12, because if you don't see that base, you know it's a common log. So you bring that exponent up first, and then if they're the same log, they're both common log base 10. You can write it once. You don't have to write base 10. And then addition goes with product, so we have x squared times 12. It's good to put the number in front of that variable, right? Coefficient. So log base 10 or log 12x squared. So same thing here, right? We brought up that exponent first, then they're the same log. Subtraction goes with division. 6 squared is first, so it goes on top over 4. And then I'll take a minute to go over one of these. So when we are expanding, right, we see one log, so we want to see more than one. We break apart multiplications, 4 times x with addition. Log base 3 of first term, or first value 4, plus log base 3 of the second. 8, we bring down that power in front. So we have 6 times log base 5 of x. Nothing more to do. Division goes with subtraction, so that's why we write log base 2 times. We know that division goes with subtraction. So it's log base 2 of the top minus log base 2 of the bottom. And next one. So be careful. You first, right? If you're expanding, you go in reverse. Reverse PEMDAS order, right? So we see multiplication, we break apart with addition. So it's log base 6 of the first 36 plus log base 6 of x squared. And if we're going in reverse order, then e comes last, right? That's why we bring down that 2 in front. And then now that we have 2 terms, we have same base, right? And we've expanded. So this one, number 11, a lot of people struggle with. So we first break apart division with subtraction. So it's log base 4, same log base 4 of the top, minus log base 4 of the bottom. Now just be careful when you're then going to continue and expand log base 4 of 3y. Notice that it's minus the quantity log base, I have to write it like this, log base 4 of 3 times y, right? 3y. Just gonna write 3y. So when you expand log base 4 of 3y, multiplication goes with addition, right? But then that negative in front, and this is where some people make a little mistake, needs to get distributed to both terms. So that's why we get negative log base 4 of 3, and then negative times positive log base 4 of y is negative log base 4 of y. Okay, and now we fully expanded. There's no more powers left, there's no more products left, and so we're done. But we technically have 3 terms. So just be careful. A lot of people, again, struggle with that one. Same number 12, a little tricky. Ooh. We see a square root, and we know square roots, we don't want to see any radicals when we're going to expand. So whatever's underneath stays in parentheses, raised to the 1/2. Now we want to drop that 1/2 on top of the 11 and the x, because it's an expression raised to the 1/2. So both of them, 11x to the 1/2, 11x, the 11 and the x, right? So that's how we get this, x raised to the 1/2, x, sorry, tired, 11 to the 1/2, x to the 1/2. Now we have product, so we break apart product with addition. So we have log base 7 of 11 to the 1/2, log base 7 of x to the 1/2. And then lastly, when we're expanding, that power comes down. That's how we have 1/2 log base 7 of 11, 1/2 log base 7 of x. And that's it. Okay, try your practice.